Hello, I'm Richard Patterson and welcome to another video presented by IPC Irwin. And in this episode, we're going to have a look at the consequences of the kinetic theory of gases, how it applies practically to a small mass of air in this tube here. So we know that the kinetic theory of gases is about the molecules of the gas moving around at very high speed, and the pressure that the gas exerts is caused by the collisions of the gas molecules on the sides of the container. So we're going to get the students to think about a container of gas which is in this tube of glass here. And we're going to heat the gas up in the tube by putting it into this water bath. And the IPC Irwin apparatus we have here has a thermometer nearby, and there's also a scale recording the volume of the gas in cubic centimetres. And what we're interested in doing is seeing what happens to the volume when we put more energy into the gas from the water bath, and we can record the temperature as the gas is warmed up. So there's quite a bit to this experiment and the theory and the thinking behind it, which I'll let you have a look at in the graphics that follow in this video. Questions that you might want to ask your students is, why does the gas change its volume when it gets more energy, and where does pressure come in there? Now, before we do the experiment, I'm going to take you through how technicians and teachers can set this apparatus up, because it does need a small preparation stage before we can carry out the experiment. So to just look at the apparatus itself, the capillary tube is open at the top and atmospheric pressure is acting down on the column of air. Now, if we want the pressure to remain constant, then we need to seal the gas in that capillary tube. It's blocked off at the end there, of course. And to do that, we're going to introduce a little plug of oil, which will, it's a one-off step when you prepare this, a plug of oil, which we're going to introduce into the capillary tube, which will seal the air in place. And I'm going to take you through those stages, initial preparation now. So what I'm going to do now is take you through how to charge this capillary tube, and by that I mean introducing a small volume of coloured oil, and I want the coloured oil to be in the tube around about the 14 centimetre mark, and it's going to be about half a centimetre long. So shake the oil up to make sure that the powder dye, the red powder dye, is distributed there, and then carefully prepare the syringe. Now, the syringe is a hypodermic, and it's been specially made so that it can slide down the capillary tube. It's a very long hypodermic syringe, so be very careful with this, and after you've used it, dispose of it safely in a sharp bin. So introduce the syringe, its needle there, and make sure that the barrel of the syringe is at the bottom there. So what I'm going to do now is open the oil and draw up some oil into the syringe and then charge the tube. Now, do take your time on this. It's quite straightforward, but if you do get air into the capillary tube and too much oil, it's not going to work well, and you're going to have to start from scratch again. So there's a little air bubble there. I'm just going to tap the syringe there just to make sure that that's at the top underneath the plunger. Okay. So I'm now going to carefully introduce the needle into the capillary tube and slide it down till it's around about the 14 centimetre cubed mark, like so. Now just apply slight pressure to the barrel and just watch the oil coming out there. I've got a little glob of oil there, and if I withdraw the syringe needle, I've sealed the gas off with that little plug of oil. Now, in older versions of this apparatus, we used to use concentrated sulfuric acid, which absorbed any moisture in the volume of air there. But with the dangers of that chemical, this apparatus, whilst it won't dry the air out as well, is a lot safer to use. And it's quite in order for you to have a class set of this apparatus, because the thermometer is integral, and it's possible for students in junior high school to investigate the gas laws at a very basic level. So what we're going to do now is introduce the apparatus into the water bath, and we can take some measurements. So I'm now going to actually do the Charles Law experiment and introduce the apparatus into the water bath. Now, before you do that, just make sure that the capillary tube, the bottom of the capillary tube, is aligned with the 0 centimetre mark there. Don't get the children to do that, because pressing the capillary tube, it could crack and cause a problem. That's something that as a technician or yourselves as teachers need to do before you issue this apparatus. And also make sure that the alcohol thermometer, the bulb there, is aligned with the 0 volume there as well, and it hasn't slipped down. So all is well here. I hope you can make out the little red pinky blob of oil there sealing in the gas. And at the moment, the ambient temperature in the lab is 21 degrees, and it's roughly 13 cubic centimetres in volume there, the sealed air from the bottom of the capillary tube there to the bottom of the index. So I'll introduce this into the water bath, and we'll do some recordings of temperature and volume as the water warms up. I'm using a flameless Bunsen burner produced by IPC Irwin here, and it's raising the temperature of the water bath. It's now reached 75 degrees centigrade, and we've had an expansion of the gas. The red seal has moved up. So I'd continue doing this until the water's boiling, and then I'd carefully cool the water and perhaps introduce some ice so that we can lower the temperature above the ambient 20 degrees. So I'll come out with a set of temperature readings and corresponding volumes, and in the table and graphic that follows, you see we've plotted those, and we've got roughly a straight line correlation between temperature and volume, showing that for a fixed mass of gas at constant pressure, the volume is directly proportional to its temperature. And it's interesting, if you want to take this further with your students, to work out how have we achieved constant pressure with this apparatus. We've mentioned atmospheric pressure is acting down on the seal, but what's happening underneath as the kinetic energy of those molecules increases and the number of bombardments on the inside of the capillary tube increases? Well, I'll leave that to you to think about if you study the graphics as follows, and thank you for watching our video. Before we give you the QR codes, we've just got a couple of pictures of the two scientists who developed this. Whilst this is known as Charles Law experiment, the actual relationship of Charles Law was pioneered by Gay Lussac. But because Charles did the initial investigations into this, he was very kindly named the law after Charles. So here's a picture of the two gentlemen. And one interesting thing is that Charles himself was a hot air balloonist, which was great because he studied the expansion of air and the gas laws. So it's not unsurprising that one of his hobbies was hot air ballooning. Here's the QR code, and there's a lot to follow up here. IPC Irwin have got all the safety and set of instructions on their website. If you go to the IOP Spark Physics site, you've got a couple of experiments on the gas laws and the kinetic theory. And our safety advisors, CLEAPS as well, have a section on the gas laws and also how to deal with hypodermic syringes in school. Thank you for watching.